7th grade lesson 9.5 is solving volume problems. So volume, we've been working on area, right? And so we have a shape and we want to know how much carpet we need to buy or how much tile we need to buy to cover it. That's area, right? Volume is if I had a shape, let me get this drawn here. I had a shape that extended upward and I wanted to fill it with water or fill it with popcorn or fill it with candy or something. So volume is about filling things up. And so when we did area, we did a measurement times a measurement, and we kept getting measurements to the second power as our units of measure answer, like 12 feet squared or 25 feet squared or 25 meters squared. When you do volume, we end up doing this dimension by this dimension by this dimension. So you're multiplying 3 dimensions together. So you're going to end up with something like feet to the third, because we're doing dimension by dimension by dimension. So it'll be to the third power, also known as cubed. So it could be like 25 foot cubed or 25 foot to the third power, something like that. So all your answers, you'll know their volume if they have the to the third power on it. So how do we find those? So we can take the same idea and say, oh, I found the area. Well, your area is going to repeat over and over and over again until it reaches the top as it fills it up. So we can use that piece of knowledge and just take that flat 2-dimensional piece of area, multiply it times a depth or a height, and that's going to give you your 3-dimensional piece. So let's just brush off some cobwebs on area, because we're going to need to know our area formulas. Because the formula for a triangular prism or a rectangular prism, for finding volume, or a cylinder, which is a 3-dimensional circle prism, is going to be volume equals this capital B. So that doesn't mean base. What that really means is the area of the base, whatever the base is, times the height or the depth of the prism. Okay, but in order to have this part down and memorized, or not memorized but done, we have to know what shape our base is and which formula to use for that. So let's do a brush off of cobwebs on our area formulas. If I have a rectangle, flat 2-dimensional, we've been doing length times width, or if it leans as a parallelogram, base times height, which is the same thing. So if we see a rectangular prism, we take the base and we get the area of that. That will give us this number, and then we will multiply it by the depth. Okay, what if it's a triangular prism? I need to remember what my area for that base is, for that for the area of the base for this number. So the area for the 2-dimensional is 1/2 base times height, because remember, the triangle can be turned into a parallelogram. You just add the other half of it, and there he is, right? So there's my formula for area of that. That will help me get that number. If it's a triangular prism, I'll find the area of the base, and then we'll just multiply it by the depth. All right, what if I have a trapezoid? This was that one that was a little harder to memorize. And again, if you need to chop it into pieces and then put it back together again, you could. 2 triangles and a rectangle. But there is a formula to make it easier. It's 1/2 height times base 1 plus base 2. This being base 1, this being base 2, or vice versa. It doesn't matter. These 2 bases get added together. You multiply it times the height, which is usually given to you, and then you cut the whole thing in half. There's your area. And if it was a trapezoidal prism, we would take that answer as the base of my area, the area of my base, and multiply it times the depth for whatever that shape is. Or if you have a cylinder, circle, the area of a circle, as you now know, is pi r squared. So I would find the area of that that would give me this area of my base, and then I would multiply it by the depth. So let's go ahead and see a few practice ones, but this is the piece of information that we need in order to fill in this part, the area of the base of whatever shape we're looking at, and then we just simply multiply times the depth of it, the height of it, or depth of it. Let's see it so we can understand it happening best. So this Bradley guy has a tent that is in the shape of a triangular prism. How many cubic feet of space are in his tent? When they ask for cubic feet of something, they're looking for that three-dimensional times the feet times feet times feet, or whatever measurement times whatever measurement times whatever measurement. Cubic is to the third power, so we know they're asking for volume. And so volume, again, is the area of the base times the depth or the height. So here's my base. It's the triangular part. So to get the area of that, so my step one is find the area of the base. So I'm going to use my triangle formula because that's a triangle. And I'll fill in my numbers. The base is 6. The height is 4. Multiply all of that together. I'm going to get 6 times 4 is 24. Cut that in half. Area is going to equal 12. Now this is area, and that's feet squared, by the way, feet times feet. This area now is the area of the base of my prism. So I'm going to call that now the area of the base of my prism, the B, for the volume formula. So I'm going to take 12 times the depth of 9, this part right here. Calculate that through, and I'm going to get 108 feet to the third power because I did feet times feet here, and then I did times feet again. So it's always cubic feet, feet to the third power. That's how you find the volume. That's how much space, cubic feet he has in space inside his tent. Okay, what if I have this trapezoidal prism? How do I solve this? Again, if we're looking for volume, to fill it up, we take the area of the base, which we're going to call capital B, and then multiply it times the height or depth of this. So the base that I need to choose, though, does need to be the shape that's being stretched out all the way back. In this case, this face of it is a trapezoid. So I need to remember my area of a trapezoid formula, because step one is find the area of the base. So just a quick reminder, formula for area of a trapezoid is 1/2 the height times base 1 plus base 2. Oh, by the way, this is 4 across here. So I will just simply plug in my numbers. Half is the number already. The height is 4 from right here, the height of the trapezoid. Times base 1 is 6, and base 2 is this matching this, which is 4. So 6 plus 4. Go ahead and calculate the addition first. A 1/2 of 4 is 2. So area of the face of it, or the base of it, is 20. So I'm going to use that in my volume formula for that. The volume to fill it up is going to be that area of the base, which in this case is 20, times the depth. In this case, this depth part is 9. And volume equals 20 times 9, which is 180. That is in the measurements of feet to the third power. We did feet times feet for area, and then times feet again for a third time for the depth. So there's the answer to that. Again, step 1, find the area of the base. Step 2, multiply it for the depth in order to get the volume of a three-dimensional figure. And oh my goodness, check out this shape. This is Allie's aquarium. She has 2 aquariums connected by a small square prism. They want me to find the volume of the double aquarium that's sitting here, how much water would be filled into it. And you're probably thinking, is there a formula for that shape? No, there isn't, but that's okay. We can just separate these through and do the volume of this rectangular prism, the volume of this rectangular prism, and it looks like these dimensions, this 4 foot and that 4 foot, this 3 foot and that 3 foot is all the same. So we really just have two of these. So if I find the volume of this rectangular prism, I'll just multiply it by 2. And then I just need the volume of that rectangular prism to add to it. So now that I have my plan, let me go ahead and get my dimensions here. I have a 3 by 4 base with a depth of 3. So I'm going to find my base, length times width, 3 times 4. So area, base times height, area is 3 times 4, which is 12. Now I'll take that number and multiply it by the height, or the depth in this case, which is 3. And 12 times 3 is 36. This one is 36 feet cubed, or cubic feet. That means this one must also be 36 cubic feet. Now I have this little guy. He's got 1 foot length here, 2 foot, looks like he's a square prism. 1 and 1, this area is saying 1. So I have 1 and 1. And then the length of it is this part right here, which is 2. So area of the base of it, this face of it, is 1 times 1, which is 1. And then volume is that number times the depth of it. So the volume of this little guy is 2. And now I just add those together. 36 plus 36 plus 2 feet cubed is a total of 74 cubic feet. So that was 36 plus 36 plus 2, the volume of each of those prisms separately added together. And so biggest thing right now is remember your formulas. You may want to write these down. Area of a parallelogram, square, rectangle, base times height, or length times width. If you have a triangle, it's 1/2 base times height. And then the area of a trapezoid, 1/2 times the height, times base 1 plus base 2. So those are formulas you'll want to have written down to use in case the face of your three-dimensional figure is any of these. You find the area. So step 1 for finding the volume of those is find the area of the face, or base. They call it the base, but either way. And then after that, you multiply that. We'll call it B. Volume equals the B from here times the depth or the height, the other dimension. Some people will give the formula as length times width times height. If it's a rectangular prism, right? Base times height times depth. So same thing. It just changes if it's a triangle. So it's probably best to just keep it in this order. You take the area of whatever the face of it is, and then you multiply that face times the depth, and there's your answer. If it's a composite figure, multiple prisms put together, find the individual prisms, add them together. That's all this lesson has you doing. So take your time, let your brain digest. You've got this.